back into the third section where we're going to start looking at the game changes involved in the infrastructure and the development of the fuel systems. To help me with this, we're going to start by looking at what's happening around the ammonia space, because I think this is one of the key developments. Now, with me in the studio here, we've got Magnus Ankerstrand from Yara and Kato Espero from Wärtsilä and Robin from Colorline. Hopefully, if you're all there. I think this is the one session where I'm actually going to be the only person on the link and everybody else is going to be in the studio. So thank you very much, gentlemen, for joining me here. And perhaps if I could just get you to talk to me a little bit about how you see the infrastructure developing. And I think what I'd like to do here is talk to Robin first from Colorline. As a ship operator, people may think, well, why didn't we have you in the first section where we're talking about the ships as well? But I also wanted to talk to you here on this section because about the need for the shipping company to be involved in the fuel supply chain. So I wanted you to talk to me a little about what you've been doing with the Green Shipping Programme and what's, I think it's with the Colour Magic you've been involved in on that, and how you see that helping you come to some decisions about your future fuel supply chains.
Yes, Greg. Yeah, it's clear, as discussed earlier here today, we need to do a change now in the shipping industry. We need to convert over to the green fuels and need to happen faster than we was seeing on the LNG business. And we are actively looking into different solutions, and we have headed a project in the Norwegian Green Shipping Programme. Then we looked into the ammonia, and we see that even for large passenger vessels, ammonia is a feasible energy, so can be used very, very soon. And we think the technology is there. We have some from the engines, and the equipment is there. We have Yara here producing the energy, and but we need to see the whole supply chain and put it together. And of course, it has some additional cost. It has additional risk in the start to set up this, and that's what we need to lubricate now. Everyone, I think we need support from the politicians. We need support from the regulatory to support us, and we need to start this train rolling now. Is what we're seeing.
But tell me a little bit about ammonia from a passenger point of view. We talk a lot in this industry, full stop, but we're talking a lot about the possibility of ammonia deep sea. But when you're looking at ammonia on a passenger vessel, such as one of the Colorline vessels, which largely go from Scandinavia or around Scandinavia and down to Kiel in Germany in places, 20-hour journeys, but lots of passengers. Mm-hmm. Ammonia is not necessarily a nice fuel to have alongside the passengers, is it? It has certain risks associated with it. So when you did the trials, when you looked through the Green Shipping Programme, can you tell me how you assessed the loading or the bunkering of ammonia when you've got a passenger vessel?
Yeah, and also the passenger ships and we as Ropax ferries, we operate from big city centers. We operate from the city center of Kiel in Germany to the city center of Oslo in Norway, and the bunkering shall, of course, also happen during this journey. And then it needs to be in the city, in one of the city centers. And we have studied the different ways of bunkering. And of course, it's not all the solutions that are available today, but liquidated ammonia, bunkering from a barge, is a solution we see is feasible today. We need to gain some more experience before we're able to put it on large passenger ships, but that experience will come very soon, and we see its possibilities there. Yeah.
Good. Mm-hmm. Magnus, let's talk about why Yara is going to become a significant fuel supplier to the shipping industry. We heard earlier today about the potential for a kind of revolution in terms of where ships are able to get their bunkers from. We have some established very large bunkering hubs around the world, in Rotterdam, in Singapore, in Fujairah. With this evolution of new supply chains, we're likely to see new players like Yara, and in the next session we're going to hear from Statkraft, new energy suppliers providing power to the shipping industry, and therefore new places that we can bunker. Why is this an exciting industry for Yara, please?
Yeah, thanks for that question. As the world's leading fertilizer producer, we're also the world's largest ammonia producer, because ammonia today is the key ingredient in nitrogen fertilizers. And of course, the shipping market, the potential of the shipping market and using ammonia as a fuel opens up a completely new market for ammonia, and then combined with the opportunity to turn the existing ammonia production, but also new ammonia production from grey to green, opens up a very big opportunity. And I think the interesting part with ammonia is that the infrastructure, to a large extent, is already there. The plant to produce ammonia exists, and it's a small portion of the entire value chain that needs to be modified by changing what we call the steam methane reforming, which today produces hydrogen based on natural gas, into electrolyzers instead. And of course, that's a huge undertaking in itself, as is the last mile infrastructure and also the procedures and safety protocols and so on that would be needed for using ammonia as a fuel. But a large portion of the value chain that's required to get ammonia from the production site to the bunkering hubs, as an example, is already there today, including vessels to ship it.
Do you see there being a huge demand for ammonia? Have you done calculations about how much ammonia would be needed if, let's say, only the deep sea shipping industry turned to ammonia? Or are you still cautious about the appetite for shipping for ammonia?
Well, I think from a total ammonia perspective, the outlook looks very promising. And I think there's as many analysis on future demand as there are consultancies around the world as well. But I think not only ammonia for shipping, but also ammonia for power production in Japan, but also eventually green fertilizers. And if you combine this, that can be quite a significant number. The big question, of course, is the timing. I don't think there's a doubt about that it will come, and it will come at a massive scale. The question is, of course, what will the timing be? And ammonia today, there's around 180 million tons of ammonia being produced worldwide today. Most of that is landlocked and goes straight into fertilizer production, and is not available for deep sea transport. Only about 25 million tons of ammonia is shipped today. And compared to those numbers, for instance, just to take an example, just the power production, or just the demand from Japan on the power production side, if you look at some of the indications from the Japanese government, as an example, could go as far as 30 million tons by 2035, which is more than the entire traded amount of ammonia today. So when it comes to the shipping industry, it's a matter of which part of the industry and when, and but I think that it will be a need for significant additional ammonia capacity in the world. That seems to me to be pretty clear.
Tell me a little bit then, this transition from grey to green ammonia. We're talking about the total decarbonisation of the shipping industry, which I think the current fuel consumption of fossil-based fuels at the moment is around 300 million tonnes, which gives about 1,000 million tonnes of CO2 up into the air every year. The transition to green ammonia surely is going to go through blue. Now, there's the question about how that is going to be accounted, but from your perspective, is that a vital part of your ability to transition to green ammonia for the shipping industry?
Well, I think green and blue will be developed in parallel, and as a matter of fact, it's already being developed in parallel. But I think in order to get at the volumes that will most likely be required, you will need blue projects as well. And the benefit of blue ammonia is that those projects are relatively easy from a technological point of view to develop. I mean, for instance, in our ammonia plants today, we capture a lot of the CO2 and liquefy it already. And obviously there's there are a lot of development that needs to happen for the actual storage. But if, for instance, look at the US Gulf, that can be achieved at both quite affordable rates, but also with quite nice tax incentives, as of course there are incentives to make that happen in Europe as well and other places. So I think blue and green ammonia is not likely to be in competition with each other, but I think to be able to cover the demand for, let's call it clean ammonia, we will need both blue and green.
Can I turn now to Cato Espero from Wärtsilä? A couple of years ago, you announced the ZEEDS project, and it was, I think at the time, one of the most, let's just say, ambitious projects that I came across with this offshore refueling idea. But I get the feeling now that it's almost become, and it's a bit like the whole industry transition that we're talking about, we need bold, ambitious ideas like this to be able to actually transition. So let's recap what ZEEDS is, can we? Because it's a large project, it's certainly ambitious, and it's to produce ammonia offshore. Is that right?
Yes. That's in a way where we started or what we presented. It was actually on North Shipping in 2019 we introduced it. It was a result of an activity that we had done together with several other Nordic companies. Actually, we tried to put together a team working cross-industry, cross-country, working on a problem. And actually, the problem was created by the task was given to us by the Norwegian Parliament, saying that we need fossil-free fuels by 2026. And I think that is that we had to start working on what could this look like. We didn't discuss ammonia. We didn't discuss any type of fuel before we actually came further out into the project, and we saw we need to conclude on something. And we said ammonia looks good. Could be good to transport, could be good to also use in combustion engines, etc. So it started like that. We launched it. It got a lot of attention. We learned a lot. And since then, we have tried to materialize this into more concrete work streams, which we are working on right now. And we also see, production of ammonia onshore. That's where it's going to start. We have looked at the blue, we have looked at the green. So the ZEEDS project, in a way, just continues and evolves in a way.
So tell me about, because this is the objective of today. I want to hear about when things are going to actually start materializing real change. When are we going to see the ZEEDS give something significant to the industries that it can have a line in the sand to say, right, we've started this transition? When do you see something concrete coming out of ZEEDS?
Well, we have, yesterday we informed about testing of the engine, where we will this year demonstrate and run the combustion engine with a fuel containing ammonia. We are working together with Grieg to develop the first ammonia-driven, which is actually a vessel that's going to move ammonia, transport ammonia, total green project, where we have got support also from the Norwegian government to develop this, and that's a research project as we speak. So that's very concrete, moving it forward to getting it started. Then we're working closely with Varanger Kraft, which have a wind plant up in the north of Norway, where they're also looking at putting together a factory to produce ammonia, and they see a lot of other types of spin-offs also from that side. So it's moving ahead, but it will still take time, I think, before we see it up and running.
But it's interesting that around the Norwegian coast, we heard a minute ago, about 10 minutes ago, about the Topeka project, where they've got the two vessels that are going to be shipping compressed hydrogen around the Norwegian coast, and now you're talking about being able to ship through the Grieg vessel ammonia around the coast. So this surely is a start of two significant supply chains and infrastructures that are going to be developing around the Norwegian coastline. But how do you see something like Zeed? Because I'm going to have a conversation with another company in the next session when we're talking more about hydrogen. But how do you see something like Zeed actually being able to refuel offshore? How can you provide an offshore refueling station for vessels? And what kind of vessels do you envisage will be able to do that? Are you looking for the offshore vessels that are going to be working around the oil and gas sector? Are you looking at Zeed being able to supply clean fuel for offshore remote locations? How do you see the Zeeds in practice actually being part of this transition?
I think starting with, for instance, fueling the offshore vessels operating out there, that's a good start, and that's actually something that we can, in a way, decide ourselves here in Norway that we want to go there. We are working on the technology now, but I think one of the important decisions or ambition we had in Zeed in the beginning is that it has to be very concrete what we are doing, and it has to be possible to be done. We have to be able to do it, I think we said within 7 years. And what we learned and what we have seen is that there's a lot of technology out there which is there already, that you can actually adjust and tune into to a new type of fuel. You need this push, you need this will, and we see that now. I think from my company perspective, in Wärtsilä we see that the interest from the customers is coming more and more. It's growing, and they want to find solutions with less CO2. So, technology is there, but it's more than technology in a way. It's a bigger thing that we need to solve. So I think that will be solved, and I think we can do this on basically, you can fuel ammonia on all sorts or types of ships, but you have to have the application in place, and of course it has to be safe. And we believe that is also very possible. I don't know if that...
Great, thanks. Yeah, thanks for that. I've just got a question now. I just want to put to Robin. Having heard about this development of ammonia, and we're going to hear a little bit about hydrogen supply chains. Robin, you've got a number of vessels in your fleet, from some very relatively young vessels, hybrid vessel. One of them's a hybrid vessel, and some older vessels. Are you concerned that this transition may leave you with a number of different fuel options for different ships, and then adding to your operational complexity in the future?
Yes, I think so. It will not be that simple that have been the last nearly 100 years within shipping. We have run on heavy fuel oil, most of us, all the time. But for the deep sea segment, I think ammonia, how I see the picture now, is going to be maybe the most preferable one. But for short distance, we will have a mix of different energy sources. You have electricities, you have hydrogen, and of course you will have biofuels probably in some areas, very well, and other type of fuels as well. So yes, I think it will be much more complex in the future. Yeah, and you need to tailor-make your vessel more.
Yeah, but you haven't actually. With the vessels you've got, with your existing fleet of vessels, are you looking at some of them and thinking, okay, we need to take these out of service before then? These are the ones that we're going to have to look at doing something with to be compliant to whatever you need to be compliant with by 2030. How are you examining your fleets? Are you actually looking at scrapping vessels? Are you looking at converting vessels? What's your strategy at the moment?
Yes, we're following that process very tightly, and of course the requirement is coming gradually, and it's an important part of this transition that we need to start with some smaller amount of green fuels. So we are looking into start to convert vessels and taking maybe 20 to 30% of green fuels on one vessel, and maybe next step is 50% some year later, and gradually change. But when you're coming to 100% fossil-free vessels, then I think we're looking very soon into new builds. Yeah. But we see it's important for the evolution here to start this gradual process. Yeah.
Good, thank you. And Magnus, just a final question to you before we start wrapping up this session. We heard from some of the international speakers first thing this morning about their desire to have a low fuel price. And I think it was the Australian participation that said $2 for out of the gates hydrogen. That's excluding the supply chain costs. I'm not quite sure what sort of volume, but I'm presuming that means that the governments are quite ambitious about having a very competitive price for green fuels. Do you see yourself able to provide ammonia to the shipping industry at a competitive price?
Well, I think first of all, one thing is, of course, the ammonia price compared to the existing ammonia prices. The other is which is relevant here, obviously, fuel prices. And I think there are several elements that need to play into this game to make it happen. First of all, of course, we will need technology improvement on the electrolyzer side to bring the cost of hydrogen down. The ammonia part of the equation is basically the same from an infrastructure point of view. And I think there's a general consensus, I would say, that we expect significant improvements on the electrolyzer side, both on the capex side and on the efficiency side towards 2030, that would contribute to bring costs down to a competitive level. I think that the major question is, of course, how do you make it work in the meantime? And that's where I think government regulation but also having a holistic focus on the value chain is very important, because for this to happen fast, we need incentives both on the technology side, on the engine side, for the consumers, obviously as well as the producers. And this will be a combination of state aid, capex support, contracts of difference. All of these mechanisms exist around the world in different shapes and forms, depending a bit on where you are, as well as technology improvements. But I think the interesting part, just to mention that, is the key position Norway has in this picture, having the combination of quite large ammonia industry today in the country, and although one plant, but in terms of volumes, it's significant. Having a large shipping segment as well, and a very competitive electricity price, and the combination of that makes ammonia production in Norway very competitive, or can make production of green ammonia very competitive. And it is a significant opportunity to reduce not only the emissions from existing ammonia production, but also from the shipping industry. So quite a big portion of Norway's commitments to the climate accord, as an example, can be taken through ammonia.
Tough enough to be on a spacecraft, light enough to be in vehicles. Some call us pioneers or enablers. Our composites technology is at the heart of what we do, and we do it with passion. Because we believe that clean air is a right, not a privilege.
The maritime industry is facing new challenges. The time to act is now. Hydrogen from renewable energy, combined with our fuel cells, will support you decarbonizing your vessels without compromising the performance. Our marine fuel cell system is developed to meet the highest marine safety standards. And most importantly, we can provide you with megawatt fuel cell solutions today. With us as a partner, your vessels will have high performance, efficiency, and safe operations, with true zero emission. It's time to move to a sustainable shipping. Join the next big wave today.